This is the Torque Command automatic transmission. It has three basic systems. The torque converter, which multiplies engine torque output and couples the engine to the gear train. The planetary gears, which multiply torque through different gear ratios. And last, the hydraulic system, which engages clutches and bands to operate the planetary gears. When working with Torque Command, you'll see some transmissions that have a lock-up torque converter, like this one. Lock-up eliminates converter slippage at highway speeds, lowers operating temperatures, and improves fuel economy. In any range except drive 3, the lock-up converter operates the same as a conventional converter. Note that the impeller is welded to the engine cover, and it turns at engine speed. In drive 3, above about 40 miles per hour, a lock-up clutch apply piston in the converter engages clutch friction material. This locks the turbine directly to the engine crankshaft. Both the turbine and impeller will now rotate at engine speed with no slippage.
To better understand the operation of Torque Command and to make your diagnosis work easier, we're going to talk to you about basic hydraulic theory, the function of hydraulic pressures, clutch and band application, and how to use this information to quickly diagnose any service problem you may have. We'll start with basic hydraulics.
In Torque Command, hydraulics principles are used to do several important things. Hydraulic fluid will transmit torque, operate valves and servos to apply clutches and bands, as well as lubricate the transmission and provide cooling. Hydraulics are the primary means of automatically engaging various transmission gears. Let's take a look at how hydraulic principles make an automatic transmission possible. This is a simple hydraulic lever. In the 17th century, a French scientist named Pascal discovered that pressure on a confined fluid is distributed equally in all directions and acts with equal force on equal areas. Here, our little man applies 10 pounds of force against a 1 square inch piston. Using Pascal's law, 10 pounds of pressure is distributed equally in all directions. By applying this same 10 pounds of pressure against a 10 square inch piston, we develop 100 pounds of force. The rule is pressure times piston area equals pounds of force. Force multiplication is used in design and operation of transmission shift valves. It's simply using a difference in area to create a difference in pressure to move an object. We now know that 10 pounds force on a 1 square inch piston will create 10 psi pressure equally and in all areas of the hydraulic fluid. 10 psi against a 100 square inch piston creates an output force of 1,000 pounds. Along with force multiplication, piston travel is considered in the design and stroke length of servo pistons in automatic transmissions. To transmit pressure throughout the hydraulic fluid, the small piston must move 10 times the distance to move the large piston 1 foot. In this case, the small piston must move 10 feet to displace an equal volume of fluid at the face of the larger piston. In addition to hydraulic pressure, spring force is also used in transmissions to modify or control pressures for valve operation. Spring force is always produced whenever a spring is stretched or compressed. This force can be calibrated and it is measured in pounds. By using hydraulic force multiplication and spring force, the operation of a valve can be precisely controlled. Here's a practical example of how a pressure regulator valve works. This valve can move in either direction to open or close a hydraulic circuit. When hydraulic input pressure, colored red, builds to overcome spring pressure, the valve moves to the right and opens the circuit. But when pressure, colored green, is added to spring force and the combined pressures are greater than the incoming hydraulic pressure, red, the valve is pushed left, closing the circuit.
The 5 points you should try to remember about basic hydraulics theory are: 1. Hydraulic pressure operates valves, pistons, and servos to apply clutches and bands, and also lubricates and cools the automatic transmission. 2. Pressure on a confined fluid is always equal in all directions. 3. Pressure times piston area equals pounds of force or force multiplication. 4. A small piston must move a much greater distance to displace an equal volume of fluid at a larger piston face, like in a servo piston operation. Fifth and last, spring force is used to precisely control valve operation. Using our basic theory, let's take a look at the hydraulic pressures needed to operate the torque command automatic transmission.
Torque command uses 6 distinct types of hydraulic pressure: line pressure, governor pressure, front servo release pressure, rear servo apply pressure, lubrication and throttle pressures, and this is the function of each hydraulic pressure. This is a hydraulic schematic of torque command. We'll use this schematic to introduce the different pressures used in drive range first gear. The line pressure, shown in blue, is used to apply the rear clutch. The primary function of line pressure is to apply clutches, bands, and servos. Governor pressure, the red circuit, senses vehicle road speed and tries to upshift the transmission. In our schematic, governor pressure flows to the 1, 2, and 2, 3 shift valve governor plugs and tries to move shift valves to cause an upshift. Governor pressure is also present at the limit valve and shuttle valve, which will control shift quality during a forced downshift. Throttle pressure, shown in green, is created by line pressure present at the throttle valve. Remember, governor pressure was trying to cause an upshift, but throttle pressure, which senses engine load, is also present at the 1, 2, and 2, 3 shift valves. It combines with spring force to provide the signal to properly time the upshift or a downshift. Lubrication and cooling pressure, controlled by the switch valve, is used to lubricate gears, clutches, bands, and at the same time cool the transmission. Converter pressure, the tan circuit, should also be noted. This pressure must completely fill the torque converter to prevent converter slipping. Also, cooling could be affected if converter pressure is too low. This is what our hydraulic circuits would look like in drive range first gear. It's the same schematic you'll see in your service manual. And the key to understanding these hydraulic circuits is to isolate each circuit function. Continuing with our different hydraulic pressures, apply pressure applies the front band in drive range second gear and manual second gear. Basically, this is how the front servo works. Line pressure is applied between 2 lands of piston. The pressure on the larger land forces the piston up so that the piston rod forces the lever to apply the front band. Servo release is accomplished during the 2-3 upshift by line pressure combined with spring force acting on the reverse side of the larger piston land. This releases the front band. The remaining pressure to consider is rear servo apply. This pressure is required to engage reverse gear and manual first. The rear servo applies the rear band. When the band is not applied, the servo piston is held in the upper end of the bore by the piston spring. To apply the band, line pressure forces the piston down to overcome spring force.
Let's sum up our knowledge about the 6 types of hydraulic pressures described so far. Line pressure is what applies clutches, bands, and servos. Governor pressure senses road speed and tries to upshift the transmission. Throttle pressure senses engine torque load and times the upshift or downshift. Lubrication pressure lubricates gears, clutches, bands, and cools the transmission. Front servo release pressure prevents simultaneous application of the front band and the front clutch. Rear servo apply pressure is needed to engage reverse gear and manual first gear. We've briefly mentioned clutch and band application in our discussion of hydraulic pressure. Now, let's learn about clutch and band application as each gear or range is selected.
In neutral or park, and while engine is running, clutches and bands are off or not applied. Moving the shift lever to drive applies the rear clutch. This clutch remains applied in all forward gears. Torque reaction through the planetary gear set locks and applies the roller clutch. This provides a final gear reduction of 2.45 to 1, which is the product of both front and rear planetary gear operation. In drive range second gear and in manual second, the front band is applied and the rear clutch remains on from first gear. Torque is now transmitted through the planetary gears in reduction of 1.45 to 1. In third gear, both front and rear clutches are applied. This locks both members of the planetary gear set together, connecting all transmission parts into one common unit from the engine to the output shaft, a 1-to-1 ratio. By manually selecting first gear, position 1, the rear clutch, rear band and roller clutch are applied. The planetary gears work the same as in drive range first gear. The difference is that the rear band is applied with the roller clutch. The rear band is what provides engine braking in manual low. Gear reduction is 2.45 to 1. Selecting reverse gear on the shift quadrant applies the front clutch and rear band. The planetary gear set causes the output shaft to rotate in reduction of 2.56 to 1 and opposite to engine rotation.
This chart summarizes application of clutches and bands in each gear. Note that the rear clutch is applied in all forward gears. This clutch band application chart can really be a helpful service tool, which leads us into our next topic. Diagnosis. It's your key to easy servicing. To do it the right way, you should understand clutch and band application in each gear and test procedures for pressure checks. But one of the first things to do after checking fluid level is road test the vehicle to verify the condition.
Let's use the clutch band application chart as a diagnostic tool. For example, any problem occurring in all forward gears would identify the rear clutch as the likely cause because it's the only component common to all forward gears. If a problem appears in third gear and also in reverse, the front clutch bears investigation. Hydraulic pressure checks are an effective means of diagnosing circuit performance. The pressures that can be checked are line, rear servo apply, front servo release, governor and lubrication pressures. Pressure test ports are provided in the transmission case. The detailed procedure to perform specific tests is described in your technical service manual. Note that a port is not provided to test throttle pressure. Symptoms that would make throttle pressure suspect are delayed part throttle upshift speeds, shifts too early in relation to vehicle speed, or engine runaway during upshift or downshift. Be sure to check the throttle linkage. If you cannot correct throttle pressure symptoms, it may be necessary to adjust throttle pressure at the valve body. We can chart pressure tests in the same way as our clutch band application chart and have another diagnostic tool. Here we see that lubrication pressure is present in all possible gear selector positions. Pressure ranges from 5 psi at curb idle up to 30 psi at full throttle. Governor pressure relates to vehicle speed and may be checked in any forward gear. Governor pressure increases in proportion to vehicle speed, approximately 1 psi per 1 mile per hour. Check your TSM for exact specifications. At standstill, pressure should read 0 to 1 1/2 psi. A higher reading could prevent downshift. Rear servo apply pressure should be present in reverse and manual first. In reverse, this is the highest pressure in the transmission. It runs from 160 to 270 psi at 1600 RPM. In manual first, rear servo apply pressure is within 5 psi of line pressure. When the selector is moved to drive, pressure should drop to 0. Checking accumulator pressure in reality is checking line pressure, which should be present in all forward gears. At curb idle, this pressure is about 55 psi and will increase with throttle opening up to about 95 psi. Adding front servo release pressure in drive third gear completes our pressure chart. Front servo release pressure should be within 3 psi of line pressure. Now, let's use the pressure chart as a diagnostic tool. For example, assume that line pressure is 70 psi and the front servo release pressure is 65 psi, a difference that exceeds the specified 3 psi. What problem could exist? Well, because the front servo controls the front band, this band could be dragging or not fully releasing. For a second example, let's assume that low pressure is noted in reverse and manual first. What's the cause? Rear servo leakage should be suspected. This kind of leakage could prevent the rear band from fully applying.
Knowing about hydraulic pressure tests is important to you, but there is a third test method you can use. It's air pressure testing, which is next in line for explanation.
Air pressure testing is used to confirm proper operation or leakage of clutches, bands, and servos. In these tests, air pressure of 30 to 100 psi substitutes for fluid pressure. Only dry, filtered, compressed air may be used. In this view of the transmission, many case passages are provided, but the only ones we're interested in for air testing are rear servo apply, front servo apply, front clutch apply, and rear clutch apply. To check operation of the rear servo, air pressure is applied to the passageway. The servo rod should extend and cause the rear band to tighten around the drum. Spring tension should release the servo when air pressure is removed. When air pressure is introduced in the front servo apply passage, the servo rod should extend and tighten the front band. Again, spring tension releases the servo when air pressure is removed. Front or rear clutch apply is checked in the same manner. As air pressure is introduced to the clutch passage, place 2 fingers on the clutch drum. Movement of the piston can be felt, and a soft thud may be heard as the clutch applies. And that's all there is to the air tests.
In our diagnosis discussion, we learned that the clutch band application chart, hydraulic pressure test chart, and air pressure tests are designed to make your diagnostic work easier to do. But that's a lot to remember. So, as a part of this film release, this booklet, A Diagnostic Guide to Torque Command, contains all the test procedures in a handy reference format. You'll want to use it whenever you service Torque Command, but it doesn't replace your technical service manual. That's always your primary reference. From our explanation of basic hydraulic theory, the types of hydraulic pressures present in the transmission when bands and clutches are applied, and the 3 diagnostic methods, you should have gained a new and better understanding of torque command. And should you find it necessary to disassemble the transmission, the bench chart furnished with this release contains detailed step-by-step instructions with photos describing disassembly and reassembly procedures.
Put it all together: the Service Training School, the TSM, the bench chart, the Diagnostic Guide to Torque Command booklet, and review this film a second or a third time. It will help you become a more proficient service technician.